welcome in this class again. Today we again start some left problems in earlier class. Actually in earlier class, due to some technical reason, we couldn't continue 1 hour class, and left portion of derivative of those function which is solved by logarithmic process. Today we discuss mainly here, and some also standard problems. First of all, I want to take some good problems. First will be this here 4a. 4a will be y is equal to x to the power x to the power x. You have to differentiate this function. As you know that there is no any formula through which you can differentiate this function. There is no any formula through which you can differentiate this function. But you will definitely think, sir, if we consider as a normal way, that means in earlier class, there will be a problem which is as x to the power x. But this is a x to the power x to the power x. Now, definitely you will fall in trouble. How can we proceed to solve this problem? First of all, you have to treat this problem as this question. Now I will tell you. Suppose that you will think automatically, sir, what happens when we take log on both sides? Definitely you will try to proceed through logarithmic process here, and when you try to proceed by logarithmic process, here you will see after taking log on both sides, here in LHS you will get log y, while in RHS you will get log x to the power x to the power x. In that case, that means I want to tell you log x to the power x to the power x. Now, which portion of this term, that is logarithmic portion, this magnitude portion, which term comes in its multiplication form? X or x to the power x or whole term? It will definitely a eligible question for you. Now I want to give you a simple problem. Can you solve this problem? And what is the way through which you solve? Definitely you will tell me, first of all, I have to find the value of 3 to the power 2. First of all, I have to find the value of 3 to the power 2, which will be 9. Which will be 9. In that case, it becomes in simplified form. Now you can find easily 2 to the power 9 will be 1. Similar way, here as you know that there is a x to the power x, but you don't know what is the value of x to the power x. But for 1 second, if suppose that x to the power x is any function which is relevant to x, definitely it will be a function which is relevant to x. In that case, suppose that x to the power x value referred as fx. In this case, it looks at x to the power fx. And while you take log, definitely it comes here fx and it adds log x. I think you understand what I want to tell you. Now, firstly rub this part, thereafter again you will understand its concept. If you understand this fact, then I want to take firstly log on both sides, right here. Taking log on both sides. After taking log on both sides, you will get in LHS log y, while in RHS you will get log x to the power x to the power x. After taking log, definitely it comes in LHS. It will definitely come in LHS. Now it will be log y is equal to x to the power x into log x. Now you can differentiate on both sides directly. You can differentiate on both sides directly. And there is also another way. As you know that x to the power x is not a simple expression that can be differentiated easily. And And I think I have already discussed derivative of x to the power x is equal to x to the power x into 1 plus log x. Still I want to tell you, it is not so easy, or in your examination you are not able to find directly if you have no more practice. That's why definitely you will take some easy method such that you can find derivative of x to the power x simultaneously during solving this question. In that case, here you see, as you know that this looks like also again a complex. In that case, again you can take log on both sides. In that case, you can take again log on both sides. You can write, or if you wish, you can differentiate here again with respect to x directly. In that case, you will again get a same answer. But in place of it, you can take log again. In that case, it becomes more easier than first case. Now I want to firstly take log on both sides. Suppose that, or if you will tell me, I can differentiate directly. First method I want to here proceed from here. Suppose that again take log on both sides. Again take log on both sides. In that case, it becomes log y, and it becomes log x to the power x into log x. I think you know very well it is as a multiplication form. Definitely log a into b is equal to log a plus log b. That means log x to the power x plus log x. Log a into log a plus log b. Now it is very simple. This is a, this is b. Log a into b is equal to log a plus log b. So it will be log a plus log b. Now this x comes here as a multiplication. That means you can write x times log x plus log x. Log x. What is this? This is equal to your log, that implies that log y. I think you understand. Log y is equal to x log x plus log x. In this question there is nothing, only you have to firstly simplify. As you see here, there is no any formula, and until this class I have not discussed as like this problem, so you can't solve by either methods. So first of all, you have to simplify this question by taking log on both sides, and you have to take log multiple times until it does not reach in a very simplified form. Now I have rubbed this part, and here you get log y is equal to x times log x plus log x. Now I want to write a differentiate on both sides with respect to x. Differentiating on both sides with respect to x. If you differentiate on both sides with respect to x, in LHS you will get derivative of log y with respect to x is equal to derivative of x into log x with respect to x plus derivative of log x with respect to x. I think you understand very well. Now, if you differentiate log y with respect to x, what will you get? Here, I want to write in very detail. First of all, as you know that log x, suppose that log y is log this log y is p. In that case, it looks as log p, and log p is firstly differentiated with respect to p. Thereafter, you can differentiate again p with respect to x, or here there is y, so you have to differentiate. But here it is given that you have to differentiate with respect to x directly. As according to this problem, you cannot differentiate with respect to x directly. That's why I will tell you firstly differentiate with respect to log y with respect to which function? Log y. Thereafter again you have to differentiate log y with respect to which function? Y. Thereafter you have to finally differentiate y with respect to x, and you have to also care on it. You have to find the value of dy dx. So don't bother by taking it. You have to find there should be a particular value as into or as it. I think you understand very well. Now you have to differentiate the RHS. As you know that there is a derivative of, you have to differentiate x into log x. It is as just a product of two functions. So you can, using rule of product of derivative, easily first of all we have to take log x out of derivative of first term, differentiate first term with respect to x, plus again take x out of it and differentiate log x with respect to x, plus similarly you have to differentiate this function log x. Firstly you have to differentiate with respect to which function? Log x, because this is your log x. Thereafter you have to again differentiate log x with respect to x. I think you understand very well. Now derivative of log y, suppose that this is your p, then thereafter it will be p. Derivative of log p with respect to p will be 1 upon p. So it will be 1 upon p. What is p? P is equal to log y. In second step, derivative of log y with respect to y will be what? 1 upon y. So it will be 1 upon y into dy dx is equal to derivative of x with respect to x will be 1 into log x will be log x, plus x into derivative of log x with respect to x will be 1 upon x. So x into 1 upon x is equal to 1, plus derivative of log x with respect to log x will be 1 upon log x into derivative of log x with respect to x will be 1 upon x. I think you understand very well. Now I want to rub this part again. Now see here, you have to find dy dx. That's why can you write here dy dx is equal to y into log y will go in RHS in numerator of a given expression or obtained expression. So can you write y times log y into 1 plus log x? I want to write as a standard form 1 plus log x divided plus 1 upon x into log x. I think you understand very well. Now what is the value of y and what is the value of log y? As you know that, always be careful in last line, and when you will get your answer in terms of y, you have to substitute the value of y by given function which is a function of x. As you know that y is equal to x to the power x to the power x. After taking log on both side, you will get log y is equal to x to the power x into log x. I think you understand very well. I have already got in first or second line when I have taken log, and I have also written in very detail, so you will understand very well. Here y is equal to what? X to the power x into, what is the value of log y? X to the power x into log x, and this is your answer, 1 plus log x plus 1 upon x into log x. In actual way, all these kinds of problem always asked in subjective. Never these kinds of problem are asked in your objective examination. Always it is asked in subjective. So don't worry by taking it. Still, if you do practice more, it will be very helpful for your easy problem. I think if you do more practice in these kinds of problems. Now, again we take next question for you, and very interesting. Only differ due to bracket, and sometimes a student having no knowledge of it and he falls in its trouble. It will be b, that means 3b, sorry 4b. Here it is given y is equal to x to the power x whole to the power x. I think there is a difference something, x to the power x whole to the power x. Both is quietly different. Both will be not same. While you calculate the value of this expression, first you have to proceed from above portion of your given question. Above portion in power form. That means in the power. From above part you have to go downward direction. But in that case you have to, as you know that it is just like a power to the power. So you can multiply. You can multiply x into x, which will be x to the power x square. So it will be very easy. So its value will be x to the power x square. Still, if you see this question, it looks as variable, that means function to the power of function, that means variable to the power of variable. Definitely, you can go through your trickery method, or second method will be take log on both sides, or you can also use it. You can also take e to the power something, as I have already told you. Take log, will be better. Taking log on both sides, you will get log y is equal to log x to the power x square. That implies that log y is equal to x square into log x. Now you have to differentiate on both sides with respect to x. After differentiating on both sides, you will get d log y dx, which will be derivative of x square into log x with respect to x. When you differentiate log y with respect to x, it will be, I want to write directly 1 upon y into dy dx. Because derivative of log y, firstly you have to differentiate with respect to x, thereafter you have to, with respect to y, thereafter you have to differentiate y with respect to x. In that case, you will get 1 upon y into dy dx, which will be, here you have to take log x out of it and differentiate x square with respect to x. Again take x square out of derivative of second function, derivative of log x with respect to x. Sometimes I will jump, so try to learn very well. So dy dx is equal to, this y will go in numerator in RHS, so y times whole expression. What is the value of y? Value of y will be, you can write as it y into its derivative will be 2x into log x plus its derivative will be x square into log, derivative of log x will be 1 upon x. So x square into 1 upon x will be simply x. So you can take again common out of it. If you take a common, you will get x times, you can take common, if you take x common, here you will get x to the power x square plus 1 into 2 log x plus 1. You can write it also as it, because if you take x common, here it is nothing, it is x to the power x square and x to the power x square, and if you take common out of it x, it will be x to the power 1. Base is same and it is in multiplication, that's why you can add its power easily, and you have to raise in it, and that will be x to the power x square plus 1, which is your correct answer of this question. I think you understand again very well. Now I want to take you for your next question, and that question is very nice here. See here. Next question for you, y is equal to x log x whole to the power log x log x. You have to find its derivative. It is also very easy, as you know that it looks as a very complex function, so you have to take log on both sides. After taking log, you have to also write taking log on both sides. You will get log y is equal to log x into log x whole to the power log x. I think you understand very well. Now you have to simplify after writing one step. Log y is equal to log x into log x into log x. You can again simplify it, log x plus log x, but don't worry by taking it. I also do not like. If you wish, I will write definitely log x. It will be log x plus log x, because this is your a term, this is your b term. Log a into b is equal to log a plus log b. That's why I want to write here log x. Now you understand very well. Now this is your log y. Now you have to differentiate on both sides. If you differentiate in LHS, you will definitely get 1 upon y into dy dx, which will be, I want to write directly. Now this is your, what is this? This is your product of two functions. This is your first function, second function. This is your first function. This is your second function. This is your first function. And if you differentiate on both sides with respect to x, first of all take out of derivative of second function first function. That means firstly take it log x plus log x, and differentiate this function with respect to x. If you differentiate this function with respect to x, what will you get? You will get, if you differentiate this function with respect to x, as you see here, I have taken this function common, and you have to differentiate this function. What will you get? You will get 1 upon log x, because you have to I know that you have to differentiate with respect to x, but you can't differentiate with respect to x. First of all, you have to differentiate log x with respect to log x, and when you differentiate with respect to log x, you will get definitely 1 upon log x. And again, you have to differentiate log x with respect to x. In that case, you will get 1 upon x as a multiplication, so you can write it directly. Thereafter, we take plus, and again take this term as a common. That means common. That means out of derivative of second term, and differentiate this term with respect to x. And if you differentiate this term with respect to x, derivative of log x with respect to x is equal to 1 upon x plus. If you differentiate again this term with respect to x, you will get 1 upon log x into 1 upon x. This is your next step for you. Now you can leave here and simply use a very big bracket. Have you understood? Now, so you can write dy dx is equal to, it will go y in a numerator as a multiplication of whole RHS, and y is equal to what? X to the power, x into log x, so whole to the power log x, into, you have to write whole expression. Here you can write log x plus log x log x into 1 upon x into log x plus, this will be log x log x into, this will be 1 upon x plus 1 upon x into log x. This is your answer. Answer is very lengthy, but if you have patience and do not do any kind of manipulation mistake, definitely you will get your correct answer. But I think it looks as very lengthy, but concept is overall very clear for you, because there is nothing in this question. Only due to lengthiness, you will sometimes face boring to solve these kinds of problem. Now, again take next question for you. Next question will be 6. Here, this is equal to y is equal to x to the power sin 2x plus cos 2x. X to the power sin 2x plus cos 2x, and you have to differentiate. It is also very easy. As that question, you have to again go through taking log on both sides. Thereafter, you will get log y is equal to sin 2x plus, you can write here. You can also direct write, because if you take log, definitely this power will come here as a multiplication of log x. So you will write here log sin 2x plus cos 2x into what? Log x. I think you understand very well. Now you have to differentiate on both sides. After differentiating on both sides, you have to again write. You will get in LHS 1 upon y into dy dx. Now here you have to differentiate, take log x out of it, and differentiate this term. You will get 2 into cos 2x, and its derivative will be minus 2 into sin 2x. I think you understand very well. Again you have to take out of it sin 2x plus cos 2x, and differentiate log x with respect to x, which will give you 1 upon x. Now simply from this line you will get dy dx is equal to y times whole expression. What is the value of y? Y is equal to x to the power sin 2x plus cos 2x is equal to, you can use here curly bracket, now this will be log x into 2 cos 2x minus 2 sin 2x plus, this will be sin 2x plus cos 2x into 1 upon x Here you have to big bracket. This is your correct answer of this question. You can see in this question again, only 2 or 3 steps is required to solve. Only it looks as very lengthy, but the concept is very easy. Again, take next question for you. Due to lengthy, I also go very slow, so that every concept becomes clear for you. Now, I want to take you a next question, question 7. See here, y is equal to e to the power under root sin x. You can again solve by taking log, but you can also directly solve differentiating on both sides. You will get dy dx. First of all, you have to differentiate e to the power under root sin x with respect to which function? You can write first with respect to x, and thereafter you have to write differentiate e to the power root under sin x firstly with respect to under root sin x. Thereafter again you have to differentiate under root sin x with respect to which function? Sin x, and finally you have to differentiate sin x with respect to which function? X. I think you understand. Derivative of e to the power something with respect to something, definitely you will get same terms. That means e to the power under root sin x. Derivative of root sin x with respect to sin x will be 1 upon 2 root under sin x. I think again you understand very well. And derivative of sin x with respect to x will be cos x. Everything very easy. Have you understood? Now I want to take next question for you again. See here, question 8. See here, in question 8, y is equal to e to the power exe has given. I think you can also solve because it looks very easy. Firstly, take log on both sides. You will get log y is equal to log e to the power x. In that case, it will be what? E to the power x into log e. As you know that in calculus, whole calculus, you until it is not given that you will always use here in base e. So log e to the base e will be 1. So finally you will get what? Log y is equal to what? E to the power x. Now you have to differentiate on both sides with respect to x. You will get 1 upon y. Dy dx is equal to e to the power x, because derivative of e to the power x with respect to x will be again e to the power x. Now so here you will get dy dx will be what? E to the power x into y. It will go right side when as a multiplication definitely. And what is the value of y? E to the power x. So its answer will be e to the power x plus 1. You can write this is addition of whole terms. You can write as it. I think you understand. This is your correct answer. This is your question 8. Now you understand very well. You can leave here also answer. If you not able to understand. Now I want to take again next question for you. 39. Very interesting. See here, because something different in that question. As a student, while he have done a lot of practice this kinds of problem, and suddenly when it comes that question, he will face a trouble to solve that question. See here, 39, and in this question he says that differentiate with respect to x. Differentiate with respect to x, as it has told you y is equal to x to the power sin x, plus sin x whole to the power x. Now how can you solve this question again? This is also very easy. Only you have to, as I have already told you, it looks as again variable to the power variable, that means function to the power function. In that case, how can you proceed? You will definitely tell, sir, firstly I will take log on both sides. But when you take log on both sides, do you know what will happen there? Here, you will take log a plus b. So this is suppose that a, this is b. It will be log a plus b. There is no any formula for log a plus b to simplify it. That's why don't try to take here log on both sides directly. Whenever it will be as a multiplication, you can take. But here you will face given expression as addition form, summation form. So that don't try to take log on both sides. Because suppose that if you take log on both sides, you will get what? you will get log x to the power sin x plus sin x whole to the power x. What will happen? Nothing. You cannot apply any property of log such that you will get in simplified form. That's why don't try to take a log. Now again I will tell you, in that case how can you proceed to solve this problem? In that case you have to suppose let u is equal to x to the power sin x and b is equal to sin x to the power x. Let u is equal to x to the power sin x and b is equal to sin x to the power x. It becomes your equation first. In that case, after supposition, then y will be what? Y will be u plus v. Y will be what? U plus v. Now you have to differentiate on both sides with respect to x using property of derivative of a addition, that means addition of two function. You can write here, after differentiating on both sides with respect to x, you will get dy dx is equal to du dx plus dv dx. This is your equation first. Second. Now you have to remember it, dy dx is equal to du dx plus dv dx. Now what will you do again? Now you have to simply find firstly du dx, thereafter you have to find dv dx and put in equation second, you will get your equal answer. This is the procedure. I think you understand. Now I want to firstly find du dx. Here you get u is equal to what? X to the power sin x. X to the power sin x. Can you write it as e to the power sin x? Don't take log on both sides. If you will tell me, I want to definitely take. First of all, take log on both sides. You will get log u is equal to what? Sin x into log x. Directly I have written it. Differentiating on both sides, you will get 1 upon u into du dx is equal to take log x out of derivative of first term. That means derivative of first term will be what? Cos x plus again take sin x out of derivative of first term as a multiplication, derivative of log x with respect to x, which will be what? 1 upon x. I think you understand. This is your expression. So du dx, that implies that du dx will be u times whole expression. What is the value of u? U will be x to the power sin x. So you can write here x to the power sin x into cos x into log x, cos x into log x plus sin x by x. This is your what? Du dx. Similar way, we have to again find dv dx. Here b is equal to sin x to the power x. If you take, can you write it as e to the power x into log sin x? Can you write? Differentiating on both sides with respect to for this both term, you will get dv dx. Sorry, after differentiating on both sides, you will get 1 upon v dv dx is equal to what? Is equal to e to the power. If you differentiate, I have, don't bother by taking it. If you differentiate, here I have solved by taking log method. Here I have solved this question by e to the power taking, that means property of log, e to the power some function. So you can, if you wish, you can take again log here. Don't bother by taking it. After taking log on both sides, you will get x times log sin x. I think you understand. Now you have to differentiate. You will get definitely 1 upon v into dv dx, which will be what? Firstly take log sin x out of it and derivative of x will be 1 with respect to x. So don't like to write here. Again you have to write, take x out of it and differentiate log sin x with respect to x. Definitely you will get cos x. You will tell me, sir, how? Because this is very easy. Firstly differentiate log sin x with respect to sin x. You will get 1 upon sin x. Again you have to differentiate sin x with respect to x. You will get cos x. Cos x upon sin x will be cot x. Now, so dv dx is equal to v times whole expression. What is the value of v? Sin x whole to the power x into whole expression. You can write here x into cot x plus log sin x. Here you get du dx is equal to this expression, dv dx is equal to this expression. Now I want to write its answer here. First we rub this above part. So from equation second, you will get du dx is equal to du dx. What is the value of du dx? This expression, that means x to the power sin x into cos x into log x plus sin x by x plus dv dx is equal to sin x by x whole to the power x into x cot x plus log sin x. I think you understand very well this question, but very good problem for you. Now again take next question for you. Everything becomes very easy for you. Don't bother. Only take patience during solving and try to manipulate correct way. Otherwise, not more complicated for you. I think as this process you can solve also question second, not more complicated. Now I want to solve next question for you. I want to one thing again. Log x. Just log x sometimes also written as ln x. But only in that case when its base will be e. Then log x can be written as ln x. So don't bother by taking it. Sometimes the students confuse what is ln x. Log x is equal to ln x. This is the compact way to write log x. Now I want to take next question for you again. See here. Next question will be second, y is equal to x to the power 10x plus sin x to the power cos x. X to the power 10x plus sin x to the power cos x. And you have to find du dx. Suppose that this is your u and this is your v, where you have to write here u is equal to x to the power 10x and v is equal to sin x to the power cos x. I think you understand very well again. Now differentiate on both sides with respect to x. You will get here du dx, dy dx is equal to du dx plus dv dx. This is equation first for you. Now in equation first you have to firstly find du dx, thereafter you have to find dv dx and put in equation first. You will get your required answer. Here u is equal to x to the power 10x. After taking log on both sides you will get log u is equal to 10x into log x. I think you understand very well. Now you have to differentiate on both sides directly, and I also want to write by step jumping 1 upon u into dy dx will be firstly take log x out of derivative of first term, which will be derivative of 10x will be sec square x, and plus take 10x again out of derivative of second term, that means 10x take out and differentiate log x with respect to x, which will give you 1 upon x. So du dx. So from this you will get du dx will be u times whole expression. What is the value of u? U will be what? U will be what? X to the power 10x. So you can write x to the power 10x times log x into x sec square x plus 10x divided by x. This is your what? Du dx. Similarly you have to find dv dx. Taking log on both sides you will get log v is equal to cos x into log sin x. Now you have to differentiate on both sides with respect to x. You will get 1 upon v into dv dx. 1 upon v into dv dx will be take log sin x out of derivative of first term, derivative of cos x will be what? Minus sin x. Again take cos x out of derivative of second term, derivative of log sin x will be what? Similar way cot x. I think you understand what is the value of why cot x, because the log derivative of log sin x with respect to sin x will be 1 upon sin x, and derivative of sin x with respect to x will be again cos x. That's why cos x by sin x will be cot x. So now from this you will get dv dx is equal to v times whole expression. What is the value of v? What is the value of v? Sin x upon cos x into this expression. You can write here firstly write cos x into cot x minus this expression, that means sin x into log sin x. This is your dv dx. Now you have to simply write your answer. Now you have to simply write your answer. What is your answer? Can I write this part? Yes, you can write. See here. This is your dy dx, which will be du dx. Du dx will be what? This expression. So I want to write here x to the power 10x plus, into log x into sec square x. Log x into sec square x plus 10x by x. This is your du dx. Plus now you have to take care dv dx, which will be sin x whole to the power cos x and into cos x into cot x. Cos x into cot x minus sin x into log sin x. Sin x into log sin x. This is your correct answer for your this question. I think you understand again. Now I will take next question for you, which is also very easy for you. And in this class, I think logarithmic differentiation overall, those problems which are solved by logarithmic process or other methods, I have discussed. You can solve these kinds of problem by 3 methods. I have already told you, but try to solve most of the question by taking log on both sides, because if you try to solve by this method, every problem can be solved. But sometimes when there are multiple variables power raised, in that case you can solve also again by same process, but sometimes you will fail. Actually you have no more practice, definitely you will fall in your trouble. See here question 40. That's why I will suggest you try to solve all questions by taking log on both sides. Next question will be fx is equal to log x to the base fx. If fx is equal to log ln x, I think I have already told you ln x is equal to what? Nothing, just as a log x. Only in base I will use always e, and there is no mention, so I will always use base e. Now you have to find the value of f dash x at x is equal to e. You have to prove value of f dash x at x is equal to e will be is equal to 1 upon e. You have to find. So first of all you have to find f dash x. What do you mean by f dash x? F dash x means, what do you know? Derivative of derivative of fx with respect to x. This represents f dash x. So you have to firstly simply differentiate on both sides. In that case you can write f dash x or df dash. You can write df dx, dfx dx. It will be differentiate on both sides with respect to x. You will get 1 upon log x and again 1 upon x. I think you understand. If you couldn't understand, I will. Sorry. There is some difference here. There is base. In base there is given x. Sorry, I have not seen properly your question. In base there is given base x. In base there is given x. I want to apply some property of log. Do you know there is a property of log? Log b to the base a can be written as log b by log a. And according to you, as you wish, you can take here in base anything. But as you know that in calculus mostly I will use always base e. So I will take base a. So try to use this property here. In that case it becomes, so from this question fx will be log ln x by log x. I think you understand very well. Now you have to differentiate on both sides with respect to x, which will be very easy for you. And if you differentiate on both sides with respect to x, you will get f dash x in LHS. And if you differentiate log x, you will get a derivative of log ln x will be 1 upon ln x. Again you have to differentiate ln x with respect to x, will be 1 upon x. Now this is your here I have taken this term and differentiate and minus. Again take this term and differentiate this log x. You will get 1 upon x divided by which function? Divided by log x whole square. I think you understand. Now you have to put in expression e, put f dash e. If you put e, you will get log e. Derivative value of log e will be 1. So don't write. If you wish, you can write. It will be what? It will be 1. It will be 1. It will be 1. It will be 1. It will be 1 upon e. So I will try to write it 1 upon e minus. It will be what? It will be what? Log there. This is what? Ln x. Ln e will be 1, and it will be 1. Log 1 is equal to 0. and this will be 0 into 1 upon x will be 0, so I will not write here. This is your 0 divided by log x. Here x is equal to log e to the base e will be 1, 1 whole square will be 1, so it will be 1, so don't write here. So finally its answer will be what? 1 upon a. I think you understand. Now again take next question for you, and I think there are mainly 2 or 3 questions for you in exercise. Next question is equal to (41). It tells you if y is equal to e to the power x plus e to the power x plus e to the power x plus dot dot dot, then you have to find, you have to prove that dy dx is equal to y upon 1 minus y. You have to prove it. If you see in this question, it follows some pattern. That means y is equal to e to the power. What is this? This is, if you see, this is e to the power x plus e to the power x plus e to the power x. Suppose that I want to cover this portion. You will get again as same question. You get again as some same question. Can you write? As you know that this is infinitely terms. As I already told you, if you take one bottle water from sea, it doesn't affect it. So as it, if you cover this portion, it looks again as a question. It looks again as a question. Above part. So can you write e to the power x plus y? Why have I written here y? Because if you cover it, it looks again as a question, and same is y. So I want to write here y. Now it will be what? Y is equal to e to the power x plus y. So if you want to write, you can write e to the power x into e to the power y is equal to 1. Now you have to differentiate on both sides with respect to x. It will be y is equal to e to the power x into the firstly take here e to the power y. If you differentiate on both sides, you will get dy dx. Dy dx will be what? Or I think you can write as two other methods. Sorry, differentiate on both sides. If you differentiate on both sides, you will get dy dx is equal to what? E to the power x plus y. Because if you differentiate it, firstly you will differentiate with respect to x plus y. Thereafter again you have to differentiate x plus y with respect to x. Now derivative of e to the power x plus y will be e to the power x plus y into derivative of x plus y will be what? 1 plus dy dx. I think you understand very well. Now it's a derivative 1 plus dy dx. So as you know that this is your dy dx, and in RHS you will again get this is what? This is what? This is y into 1 plus dy dx. So if you manipulate it, you will get in LHS dy dx, and in RHS you will get y plus y into dy dx. If you take this term in LHS, you will get to 1 minus y into dy dx is equal to what? Y. So dy dx will be what? Dy dx will be what? Y upon 1 minus y. This is your answer of this question. I think you again understand this question again very easily. Now I want to take again next question for you. Next question also looks at same it. Next question here something different. See here, in this question it has given that if x is greater than 0, see here carefully 42, if x is greater than 0 and x to the power y is equal to e to the power x minus y, then prove that dy dx, then you have to prove that dy dx is equal to log x upon 1 plus log x whole square. I think you understand it very well. Now I want to solve it. See here, this is your question, x to the power y is equal to e to the power x minus y. Have you understood? Taking log on both sides, you will get definitely y times log x is equal to what? X minus y into log e to the base e will be 1, so I don't like to write here. Now you have to differentiate on both sides with respect to x. In that case you will get log x into derivative of y with respect to x, and y derivative of y with respect to x will be 1 upon x, and its derivative will be 1 minus dy dx. I think you understand very well. Have you understood? Now here if you take this dy dx in LHS, you will get log x and as you know that its coefficient will be minus 1. If it comes in the left side, you will get 1 plus log x into dy dx, which will be 1. It will get in right side, it will be 1 minus y upon x. Have you understood? Now, what is dy dx? So you will get from it dy dx is equal to, if you take its LCM, you will get x minus y by x into 1 plus log x. Have you understood? Now, x minus y into x into 1 plus log x. Have you understood? Now, here, again, after here, you will get dy dx equal to x minus y upon x, and you have to get it as this expression. Now you can try to here again. Here it is very simple. From this, what will you get? Can you put here from this is your first equation. Now suppose that this is your first and this is your equation second. This is your equation first and this is your equation second. So x minus y. So right here value of x. So x is equal to what? From this equation, can you write from equation first? Right here, from equation first, x is equal to what? Y into 1 plus log x. Can you write? Y into 1 plus log x. Can you write? Now if you put y into 1 plus log x, you will get in denominator. So, and this is your first part, and in second part x minus y is equal to y into log x. Now this is your, suppose that this is your equation third. Have you got? Now put in equation second, first in equation second, value of equation first and third. In that case, you will get dy dx is equal to x minus y is equal to what? Y into log x. So you can write y into log x directly divided, right? In denominator, x into 1 plus log x. So I want to write x into 1 plus log x. Firstly, write 1 plus log x, and value of x is equal to what? Y into 1 plus log x. Y into 1 plus log x. Have you understood? Y cancel, so it will be directly log x divided by what? 1 plus log x whole square. This is your RHS. Only sometimes it will go definitely during solving. Sometimes you will reach at that point. Thereafter you have to again think what will I get. Sometimes you can directly reach at this stage. Sometimes it takes some steps, because I have not thought during solving what I have to get. So in final stage I fall in trouble. But don't worry, by taking it by any procedure you can reach at this stage. Now again I will tell you, in next class I will discuss some different topic, that means in which I will discuss mainly about derivative of derivative of determinant, which will be very interesting topic, and as well as some complex and mixture topic. I think there are more than 7 to 8 class, and I will also discuss some objective kinds of problem, and from which topics more probability to ask questions. As you know that in this from this topic there is less probability to ask question objective, very less probability. Still I will discuss some standard type which may be asked during examination, as x to the power x, derivative of x to the power x may be asked, and its answer will be x to the power x into 1 plus log x. Very easy, and similar way may asked in your examination, x to the power sin x or sin x to the power x, or everything. All these problems are very easy. And in next class I will discuss firstly your next topic, and in that topic will be your higher derivative, that means successive differentiation. In next class I will discuss what do you mean by higher derivatives and successive differentiation. Very interesting topic, as well as very easy, not more complicated as it, but very easy topics. You can solve very peacefully all those concepts. Thanks all of you, and in next class I will again discuss with you successive differentiation and higher order derivatives.